A very warm welcome to this session where we are going to discuss in detail about VPC, which is the Virtual Private Cloud, and it is a very important topic when it comes to the AWS Solutions Architect series. Because in AWS Solutions Architect, we create a lot of different resources. We understand how those resources interact together so that we can create the required solution for the end user or the customer. But in order to create all these, you need an environment where you can place these resources or create those resources, right? And that's why we very critically, that's why we use virtual private cloud a lot. Now we already know what is cloud. We've also understood what is private cloud. So what is this virtual private cloud? So when it comes to private cloud, we know that it's an environment which an organization has created where they host their own systems so that they can host their websites, either public facing or internal, or they can have several applications running there so that the users within the organization can use it irrespective of where the actual servers are located. So if that particular organization has the presence in multiple regions or different countries in all over the world, they can have a main data center in one place, and that can be shared among different countries of that organization where they are located. But that's a private cloud, right? That's a private cloud which only that organization can use. But right now we are discussing about AWS, Amazon Web Services, which is a public cloud. That means anyone like you and I, we can create our resources on AWS, our public cloud. So the virtual private cloud gives you the ability to create your own isolated cloud environment in the public cloud called as AWS or Amazon Web Service, right? So let's see here what exactly, how is it defined. So a virtual private cloud is a virtual network that allows users to create logically isolated networks. So it is not physical, it is logically isolated networks within a public cloud environment. So we are creating our resources on the AWS public cloud, but we are creating a logical separation between the actual physical infrastructure so that we can keep our resources absolutely private. It provides a secure and private space for hosting resources like virtual machines, storage, and databases, all within a cloud provider's infrastructure. Think of it as a way to have your own private network within a larger shared cloud environment. So what does this mean? So just imagine, now we are discussing about virtual private cloud here. Just imagine any large organization that you may already know of in the field of IT. Let's say this is something like Accenture, all right? So we know that Accenture works with a lot of different clients, and let's say that Accenture has its own servers and databases, everything running on AWS, all right? So let's say that this is the Accenture AWS infrastructure, okay? And let's say that there is another organization. So the second company is Cognizant, and they also have their entire infrastructure set up on AWS. So let's say that this is the Accenture AWS environment, this is the Cognizant AWS environment, or let's say that there are other organizations here as well which are hosting their resources on AWS. Now this organization may have a few EC2 servers here. Let's say that there are some servers, okay, and then there are some databases also. Similarly, Cognizant may also have certain servers, and it may have certain databases running here as well. All right. So some servers and some databases. Now, would it be acceptable because they are all under the actual environment of AWS, right? So they are all in the actual physical infrastructure of AWS. Would it be acceptable that because they are in the AWS environment, Cognizant is able to access the databases of Accenture, or the Accenture servers are able to access the databases of Cognizant, so on and so forth, or accessing other resources which are hosted there? Would it be acceptable? Not at all acceptable, correct? Be it any organization, it would be an absolute disaster. No business can run like that. So there are many regulations and compliance requirements in place which ensures that no data from one organization should be shared with other organization. There will be a lot of personally identifiable data, customer data, and a lot of things. So we have to make sure that any organization which is hosted somewhere, their data is absolutely safe and secure, correct? So in an environment like AWS, where we have seen they have multiple regions all over the world, they have several data centers, and those data centers are actually used to host the resources created by different organizations or different individuals like you and I. So I can go and create a lot of servers there. I can host my application, same physical data center. There are other organizations, large production organizations, which have customer data of millions of their customers hosted on the same physical data center, correct? So it is absolutely unacceptable that someone will be able to access the data from someone else, right? That's why we need a logical separation between the different users or different clients of AWS. So for example, I am creating an account on AWS, someone else is creating an account. They are logically separated in such a way that from my account I will not be able to see or access anyone else's data on hosted on AWS at all. That's why it says here it provides secure and private space for hosting resources like virtual machines, etc. Okay, and what does it say here? It allows users to create logically isolated networks within a public cloud environment. So we are on a public cloud environment, which is AWS, but we are still creating resources which are absolutely logically isolated from each other. Let me give you another example. So it's just like, if I give you an analogy, it's just like a let's say this is an apartment building. In this apartment building, you have several apartments where there are different people staying or living, right? So let's say in this apartment building there are 5 or 6 different apartments, and there could be different people living here. Let's say that there is a couple living here, right? And there is a single person living here. Maybe there over here there is a family, large family living, correct? So irrespective of who is living where, in which house, nobody can interfere with each other's uh, privacy here. So if you see, this large apartment building is one structure, so all these apartments are within that same structure, right? And all these people are within the same one structure of that apartment building. But within that apartment building there are different sections or different separations called as apartments. Now this first family, this couple, they can do whatever they want in their home. Maybe they are playing some loud music, right? They're playing some loud music, but as long as they are keeping it within limits, they are not disturbing anyone, they can do whatever they want within the boundaries of their own home, right? And maybe this family, they are cooking whatever kind of food they want, right? But they are doing it within their own apartment, they are not disturbing anyone. So they are free to do that because it's their own apartment, it's their own private space. And there, in the language of AWS, we can say it's their own virtual private cloud. So although this entire apartment building is one unit, within this one unit there are different apartments or different houses in which there are different people who can do whatever they want within their own private space. So this is exactly how AWS also functions. So this is the AWS environment that we have, the orange box. That's the physical data center of AWS, and within that, we different organizations or different users like you and I, we create our own accounts, and within those accounts, we are creating our virtual private cloud. So that virtual private cloud gives us that isolated environment where you can host any number of resources without the fear of someone else accessing it or hacking into it, because it gives you a clear logical separation that no one can hack into it, no one can access. So that's why all these different organizations, including you and I, we can create our resources on the data center when we are creating the virtual private cloud, and there is no intermingling or there's no interaccessibility of the resources at all. So let me show you how do you actually create the virtual private cloud. Okay, so in this case, again, we have made it clear that the virtual private cloud actually creates a very secure and private space for you to host your resources. The resources are several, like virtual machines, storage, databases. We're going to see a lot of other things as well. And so the entire public cloud, right, whenever you're hosting your resources on public cloud, there's always the concern that will our data be safe and all. So in this case, when you're creating a virtual private cloud, your data is absolutely safe. It is within the boundaries of your own virtual private cloud. Only you can access it, no one else can. Okay, so once we see how to create it, we'll understand it better. So now, there are different components within a virtual private cloud. Once you create a virtual private cloud, as such, you cannot really use it to do much. But within that virtual private cloud, there are other components. When you put together all those components, then you are able to use it for a lot of different kind of things. So we are going to see one by one what are the different components, what is it actually used for, and how do they all come together to give us an entire ecosystem through which we can host our resources absolutely securely. Okay, so let's now understand how do you actually create a virtual private cloud and what are the different components within it. Okay, so how do you what are the different aspects, what are the different components, or what are the different values that you need to put in to create a virtual private cloud. Okay, so I just come to my AWS Console homepage. Here on the search bar, I just type VPC, and this brings me to virtual private cloud, which says isolated cloud resources. So I click on this VPC, and it brings me to this page. So most of the resources that we create on AWS, guys, or any other cloud for that matter, what it does is when you come to that resources homepage, it'll give you a list of a kind of a form where you have to put in all the different details that you want, and based on the information that you're feeding into creating that resource, it will create that resource for you. Okay, so for example, now I click on this create VPC. It will ask me for certain details. When I feed those details in, it will create the VPC according to that. Now, when I come to VPC, there are two different ways that I can create a VPC in. Earlier, there was just one available, a manual way to create a VPC, but now they have brought in a more easier and automated way to create a VPC. I'm going to still guide us in the way of the manual VPC creation, because that gives us a very good in-depth understanding about what is actually happening in the backend, so that we are able to create the VPC. Once we understand that, creating the VPC automatically is a piece of cake. So we'll go the manual way. So here we are on the page where we understand how to create a VPC. So here, if you see, a VPC is an isolated portion of AWS cloud populated by AWS objects such as EC2 instances, and so this is what helps us to create that environment, that isolated environment where you can build your resources. So here it comes to VPC settings, resources to create. So first I'm going to select VPC only. Okay, so if I say VPC and more, there are other aspects, like I told you, the other components related with VPC. It will allow us to create everything together. So as I change the settings here, if I select VPC and more, so just let's say that in the name of project, I change it to demo. Okay, you'll see that here everything changes. The VPC name changes to demo VPC, and it is creating something called as a subnet automatically for you, for me, right? So if I say demo here, it names it again as demo, right? So if I say something like demo AWS, right, you'll see that it automatically changes the name here in demo also, and under the subnets also, right? And similarly, it will create something called as a route table also, and here also it will change the names. So this is the more recent automated way of creating everything quickly, but we are going to understand it more in depth through the manual process. Okay, so let's do that. So I'm going to not select VPC and more. I'm going to select only VPC. Once we have created the VPC, I'll explain to you exactly what is subnet, what is route table, why do you need it, how do you use it. We'll see all that. Okay, so I come to VPC only, and now here I give a name to my VPC. So for now, I'm going to keep it simple. I'm just going to call it demo VPC. All right, so demo VPC, and here it asks me for IPv4 CIDR block. So whenever you're creating a VPC, virtual private cloud, what is that? It's actually nothing but a network. It's called as a super net or a large network. So when you're creating a large network, within that network you can create different resources. So I'm sure all of us know about what is a IP address, right? So any device that we use, that device, irrespective of what kind of a device it is, if it is connected to the internet or any network, it will have something called as an IP address. And there are different types of IP addresses. So we are going to understand something called as what is an IPv4 CIDR. Okay, so I'm sure we already know about it, but I'm just going to direct you to certain resources which can help you understand that a lot more. So I search for IP address here in Google, and I can go for the Wikipedia page. So here it tells me everything about IP address, how an IP address is formed. I'm sure we all know about this. And then one more important resource to go through is called as CIDR, which is classless interdomain routing. So make sure, if you're not aware of this, you go through these articles. It will help you to understand VPC in a much better manner. So what is classless interdomain routing? What is the exact um, notation in how you define it? So you have one IP address, then you have a slash, and then you have the subnet mask. So how does that work? You need to understand that really well to understand VPC. So make sure you go through IP address in detail, then classless interdomain routing in detail, then understand what is a subnet. Okay, so subnet means sub network, which is a smaller section of a larger network. So in this case, as we are talking about VPC, virtual private cloud, so virtual private cloud is a large network. Okay, it's a large network that we are creating, and then within that large network we will now create smaller networks. Okay, so that we can keep our resources within the large network itself separately. Okay, so first we create our large network. So let's say that this is my VPC, correct? This is my VPC, and within the VPC I'm going to create smaller networks. So let's say that this is my subnet 1 and this is my subnet 2. So what is a subnet? A subnet is nothing but a sub network. That means a smaller network. So VPC is my large network or my super network, and these are the smaller networks which are within the VPC, which are the sub networks. Okay, so how do you actually use them? That's what we are going to understand. So first of all, to create a network, you need an IP address range. That is what is defined by the CIDR that we saw just now. Classless interdomain routing. This helps us to get the CIDR range. And then you have to get the actual IP range that you can use for the VPC. So if you search for something called as private IP ranges, okay, if you search for private IP ranges, you'll know that there are only three different ranges that you can use for private networks. So there is public IP range, there is private IP range. So every IP address that is assigned over the internet is called as a public IP address, and that is assigned through a public IP range which is assigned to your internet service provider, and they assign it to the devices which are connected to their network, right? Apart from that, you have a private IP network. So these are the three IP ranges majorly which are used for private IPs. That means in the internal networks that we have, so maybe for example my home or my office or all the different office locations that we have, they will all use the same private IP ranges that you see here. Why is that? Because it is private, it is not conflicting with each other. So if one device over the internet has one particular IP, in the entire world, except certain scenarios, no other device can use that same IP address because it's public. No two devices can have the same public IP address. But when it comes to private IP addresses, because those private networks are isolated from each other, you can reuse the same network. That's why, let's say that there are two different office locations. One belongs to Accenture, one belongs to Cognizant, and they are both physical networks, office networks. They can both be using the same IP range, something like something the series of 10.0 something something. Okay, so they could be both using the same network ranges. They actually do. and because they are not interconnected, there will be no conflict at all. So make sure that you are understanding this private network IP ranges really well. So in this case, in VPC also, what we are going to do is we are going to take a private IP range to create our large network, as I've shown here, large network or the supernet, to create our VPC. This will be our own private network. So what do? I mention that IP range here. So as I told you, there are only 3 IP ranges from which you can select the IP address range for your VPC. So I'm going to select something like this, 192.168.0.0/16. Okay, so when I'm selecting /16, it means that no, I'm just breaking that large network into some smaller networks, and then we will be able to break it further into smaller networks. So make sure you understand how subnetting works as well. So just search here subnet and understand how subnetting works, and then you'll have a very clear idea about what we're doing. So here I'm going to select an IP range called as 192.168.0.0/16. Okay, so if you see here, it says CIDR block size must be between /16 and /28. So you can take anything like /16, /17, /18 or something like that. So depending on which slash value you're taking, what it determines is how many networks you can create. And further, when we are talking about subnets also, it can determine how many devices or how many hosts you can have within each subnet, based on how many IP addresses you will be able to create. Okay, so make sure you understand how CIDR works. So here I'm taking 192.168.0.0/16 as my VPC CIDR range. Okay, that's all. So that's all you have to do to create your VPC. It's as simple as that. So what do? You give your VPC a name, and then you select the IP range that you want for your VPC. Now, you can have multiple VPCs with the same IP range because they are all multiple isolated networks. There will be no conflict. But there will be certain scenarios if you are peering those networks, if you are peering those VPCs, that means you are interconnecting those VPCs, then it will not be applicable. So you have to make sure, if you're peering, if you are planning to peer or planning to connect 2 different VPCs later on, you need to make sure that you're initially itself you're creating different IP ranges for both the VPCs. So we'll understand VPC peering in the other video that we have in detail. So here I've taken the CIDR range for VPC as this. Now all I have to do is just click on this orange button which says create VPC, and there are a lot of other things that is happening in the back end, but in the front end this is all you have to mention. So we mentioned the name of the VPC, we gave it the IPv4 CIDR range, and now you see it says you have successfully created your VPC, and there are a lot of other information here as well, and we'll go through all that. So once your VPC is created, you cannot really deploy your resources directly to your virtual private cloud or the super network or the large network. You have to create smaller networks called subnetworks within which you will deploy your resources. Okay, so how do we do that? On the left hand side on the panel, you see, so we are on the main console of the VPC, virtual private cloud. On the left hand side, if you see here, there is a section called as subnets. So now we click on subnets. Okay, so this is my demo VPC that we just created. If you see here, it shows the CIDR that we selected, 192.168.0.0/16. So on the left hand side, I select here subnets. So I click on the subnets section there, and I see the subnets. Okay, now we may think, what are these subnets which are already existing? So these subnets are part of a VPC which is already present. Okay, so if you see, it shows all these 3 subnets belong to the same VPC. So here, see here, the subnet has an ID which is different from each other. So this is 9C, this is AF, this is 13, but they all belong to the same VPC called F4, ends with EF4, right? So what is this VPC? So if I go to our VPC section again, if I come here, you will see the VPC that we created, which is called as demo VPC. it has the naming convention called it has the nomenclature 0E0, but this is the other VPC which is existing, EF4. Okay, so there was already a VPC existing, but we created another VPC. So what is this existing VPC? So the difference is seen here. If I scroll to the right, you'll see that there will be one column which will differentiate these two. So if I scroll here, see here, there is a column called as default VPC. So the first one says no, the second one says yes. So the one that we created is marked as default VPC no. That means the one which was already existing, that is a default VPC. So what is a default VPC? Very simple. AWS already provides us an isolated network, so that in case we want to directly deploy a server or a database, we can deploy it to that particular VPC. Okay, and in my other videos you can see where I'm directly deploying an EC2 server, I deploy it to the pre-existing default VPC as shown here. Why is that necessary? Because there may be some people who are testing the AWS environment. They may not know much about VPC, etc., but they just want to deploy a server so that they can test some application or something. But we are, as solutions architect, we are going to learn everything in depth. That's why we are understanding how VPC actually works and how to create that ourselves, right? And why should you need to create a virtual private cloud by yourself? Because in many cases you might require a virtual private cloud and the underlying subnets which has the specific IP range that you require, right? Even if you are deploying multiple virtual private clouds, as I told you, and you need to interconnect them for communication between those networks. In those cases, you will have to assign different IP ranges to different networks, right? So in those cases, you have to create your own custom VPC, and that is why we have created our own custom VPC with the IP range that we want. So the predefined IP range is existing, but that's not something that you may want when you're deploying multiple networks. That's why we create our own virtual private cloud. So you have to pay attention when you're creating a virtual private cloud, when you're creating subnets, how are they interconnected? If you're working on a particular subnet, which VPC does it belong to? So we have to be careful on that. So I click on the subnets section again. Now here again, if you see, all these three subnets I told you are connected to the same VPC, and that's why, because the VPC is a default VPC, all these three subnets are also, if you see here, they are default subnets. They are pre-existing subnets created by AWS in advance for us. Okay, so now we are going to create our own subnets. How do we do that? On the top right here, if you see, I click on this create subnet, and when we are going to create subnet, it asks me under which VPC do you want to create these subnets. So at present we have two VPCs. One was the default one, see here it mentions default, and the other is the one that we just created. Okay, so in case you have created more VPCs, it will list all those VPCs under this region. Okay, it will not show you any other VPCs from some other region. It will only show the VPCs which is under this region. Okay, so which region are we in? If I go to the top right corner, it shows here Asia Pacific Mumbai, right? So if I select that drop down window, it shows all these different regions which are available, and I am currently working on the Mumbai region. If I select some other region and I go to that region now, I will not be able to see this particular VPC that I'm working on. Okay, so a VPC is a region specific network. So currently I'm working on the Mumbai region. So I'm deploying the VPC across all the data centers or all the availability zones of the Mumbai region. Okay, so it spans across all the different data centers. And now when we are creating a subnet, because I told you a virtual network is a VPC is a logical entity, correct? So it spans across all the different data centers across the region. So it's a regional service. But when we are creating a sub network, that exists in one particular availability zone. Okay, so if I show it in a diagram, it looks like this. So a VPC is a region specific, spans across the region, but a subnetwork will be limited to one availability zone, right? So this will be my availability zone 1 and availability zone 2. Subnets will be in availability zone 1 and availability zone 2. So this is what helps you to deploy your databases and your servers in different availability zones, so that even if one data center or one availability zone becomes unavailable, your service will continue to run from the other availability zone or data center. Okay, so we were here creating a subnet. So when we are creating a subnet, it asks me to create it in a particular VPC. So I select which VPC do I want to create it in. So I select this demo VPC. So when I select the demo VPC, it shows the exact IP range that I have here. So when it gives me the IP range, I scroll down, and now I can create my subnetworks within this IP range only, right? So I scroll down and I give my subnet the name. Let's say that's something like demo subnet 1. Okay, now I have to select which availability zone do I want to deploy it in. So as I told you, my subnet belongs to one particular availability zone, right? And most of the times there are 3 availability zones in each region. So I can deploy this particular subnet in any of the 3 availability zones. So I have 1A, 1B and 1C. So let me deploy it in 1A. Right now, for this particular subnet, I have to give it a CIDR block range, correct? So the VPC block range is already selected here, 192.168.0.0. So the subnet is defined by the third octet, right? So the network is defined by 192.168. These are the 2 octets which define the main network, that is the VPC, right? But the third octet is the one which defines the subnetwork. So now that we are creating the 2 different subnetworks, both will be within the same VPC, correct? So if my VPC is 192.168.0.0/16, what this means is there are 4 different octets. So if you see, if you go and check the binary equivalent, you'll know that there are 32 bits here, 8-bit in each octet, and /16 just means that we are breaking the network from here, right? We are breaking the network from here. So the front section is what defines the main network, that is the VPC. That's why for the subnetwork, the first 2 octets will remain the same, 192.168, and the third octet is what defines the subnetwork. So I'm going to keep it as 1 here, and then the fourth will remain the same because that is what will be taken by the actual device within this subnetwork, right? And this will be 24 because now it is the first 3 octets belong to this network, right? And similarly, the fourth, so the next subnet will have 192.168.2.0/24. Okay, so you can understand how the subnet, when we understand how subnetting works, you'll understand how the subnet octet is defined here. Okay, so these are the subnet ranges that we have. So I just go ahead and select the first subnet range here, 192.168.1.0/24. You can even take /25 or /23 or /22, depending on what you're taking. The number of IPs that you get will differ. So if you see here, when I type 24, I get 256 IPs, right? So you don't want too many IPs in your network. At the same time, you don't want too little number of devices also in your network, right? So you want to keep it somewhere in the middle where you have a good number of IPs within the network. So that's why we take /24. Here I get 256 IPs within that subnetwork, so that I can have 200 and around 220 251 devices, either servers or databases, because 4 or 5 different IPs are reserved for certain different tasks for AWS. So if I say 23 here, you see the number of IPs immediately doubles. But I don't want to, in case you don't want to manage that many devices within a network and you don't want to waste many IPs also, you can just keep it as 24, which gives you a fairly decent number of IPs. Okay, so this is my first subnet, and let's say that I want to create another subnet here. So I'll click on add new subnet, and I'll just give it a name here. I'll call it demo subnet 2, and then I will keep the availability zone as 1B here. So these are two different availability zones where we are deploying our both subnets, and then I will give it a range called as 192.168.2.0/24. Okay, so here also I get 256 IP. So what did we do? We created one virtual private cloud, then we created two different sub networks in two different availability zones, and I click on create subnet. So you can create multiple subnets together, and these two subnets have been created for me. So if you see here, the names are defined here, then AWS automatically creates a subnet ID which is unique across the entire AWS environment. So this is the ID which it has assigned to our subnets, and then both these subnets are now available, and under these subnets, both these subnets are within the VPC, the same VPC, that is the VPC that we had created called as demo VPC. Okay, and if you see, the range has been assigned exactly the way we have defined 192.168.1.0 and 2.0. And if you see, both of them can have 251 devices or resources or servers or databases, 251 IP addresses within that network. Okay, and they are both in two different availability zones, 1A and 1B, which means there are two different data centers within the same region, Mumbai. And then we'll learn about route table later on, and these are both not default subnet. That means they are both created by me, not assigned by AWS themselves. Okay, so these are the information that we have now. We'll understand how do we create resources, how do we create servers, databases within these subnets in the upcoming video. But now if you see, if I click on any one subnet, you'll see all these details about the subnet, which we'll understand in more detail. So this is the subnet. How do you create resources within the subnet? How do you create a route table in the subnet to manage the traffic flow within and outside the subnet? All that we are going to see in the upcoming session. So in this session, we have seen what is a virtual private cloud, how do you define the IP range for a virtual private cloud, how do you create the subnets within the virtual private cloud, how do you define the IP ranges. Now in the coming videos, we'll see how do you utilize the virtual private cloud and the subnet to deploy your resources and use them, interconnect them. Okay, so I hope this video was informative for you. Thank you for watching.